bit past our time, and we will start the 7th seminar in our Early Career Researchers series. This is a seminar that is curated by the International Water Management Institute. We do this on every third Monday of every month, where an early career researcher from outside the CGIAR system, outside EME, comes and presents to us some interesting piece of their own research. And this is, of course, open to also for participants outside of the EME. So these are open for all webinars. So in this month, we have with us, this is the 7th seminar, as I said, and we have with us Dr. Shreya Banerjee. She is a postdoctoral fellow in Singapore Management University, and she's working on a project called Cooling Singapore. Her research focuses on human thermal exposure, heat mitigation, and adaptation in outdoor spaces, and also on climate action policies and resilient settlements. Shreya pursued her PhD from IIT Kharagpur between 2017 and 21, during which she was also a visiting scholar at the Arizona State University. She was awarded the Bhavan Fellowship from the IUSSTF, jointly sponsored by the Department of Science and Technology, Government of India, and the US Department of State in 2019. Shreya completed Master of City Planning from IIT Kharagpur and Bachelor's of Architecture from IEST Shibpur, West Bengal. She has published in journals such as Science of the Total Environment, Urban Climate, Landscape and Urban Planning, and International Journal of Biometerology. Shreya is in the invited expert panel of Ministry of Housing and Urban Affairs, Government of India, and German Agency for International Cooperation for developing of design standard of thermally comfortable, affordable homes. She is a member of different professional bodies such as International Association of Urban Climate, European Geosciences Union, etc. So I think that is an extremely important topic of how do we cope with the kind of extreme heat events that we are seeing. And this is not traditionally the work we at EME do, but we, of course, are very interested in learning more about heat resilience plan and what does that kind of high level of heat can do to a human body, and how are people, particularly in informal settlements, are coping with those heat. So I pass on to you, Shreya. You may want to switch on your video and share your presentation. You will have around 30 to 35 minutes for your talk, which will be followed by a question and answer session. So over to you, Shreya, and welcome and thank you for being our early career researcher presentation this month. Over to you.
Thank you, Aditi. And I would like to thank IWMI for giving me this opportunity. And it's always great to talk about your research. And since this research is very relevant now, keeping in consideration the climate change aspect and also the urban poverty and informal settlement aspect, this is, I think, is pretty significant. And I'm really passionate about this particular topic. So without any delay, I'll share my screen and can somebody please let me know if this is visible?
Yes, it's visible. Yeah.
Oh, perfect. So thank you everybody for joining. Today I'm going to talk about the thermal exposure of workers and outdoor microclimate in informal mixed-use areas in Kolkata, which is part of the hot and humid climate category. So before I get into the detail, I'll quickly give the context that I'm an architect urban planner, and later I did my PhD in climatology. And that's when I started developing my interest towards heat mitigation. And I'm presently working as a postdoctoral research fellow at Singapore 88 Center and Singapore Management University. So talking about climate change and sustainability, we all understand that it's a new concept. Previously, there was no such concept of sustainability existing. So it's a new concept, and along with that newness in this concept, a lot of ambiguities also come. So we all are aware that post-1950, urbanization took a different trajectory across different parts of the world, and slowly the sustainability thing came into practice, especially after the Brundtland Report in 1987. After that, Rio Earth Summit in 1992 put a lot of impetus on climate context in urban planning, followed by the Kyoto Protocol, Bali Action Plan, as well as the COP21 which is popularly known as Paris Agreement, and that happened in 2015. And after that, the formation of Sustainable Development Goals happened. And my work is actually associated with four Sustainable Development Goals. They are Goal 3, which is improving the health and well-being. Goal 7, which is I think the green and clean energy. Goal 11, which is the sustainable city community, as well as goal 13, which is about providing climate justice. So, talking about why all of these are important, we all are aware that Global South is already a critical place, a critical geography where there is a lot of injustice happening in terms of resource distribution or like urban poverty and such things. And on top of that, heat waves are very prevalent in this part of the world, especially in South Asia and some other parts of North Africa as well. We all are aware that India and Pakistan struggled really bad in 2022 heat wave with a lot of fatalities. So this sets the context of my research. So I have been working on heat mitigation since 2015, and I have realized that informal spaces in the urban areas are one crucial area where very less amount of research was done till the time I was joining PhD and considering a topic like this. So what makes the situation in Global South worse? Firstly, population is huge. We live in a country of 1.4 billion where equal distribution of resources is not possible in terms of, um, say, environmental upgradation or like proper housing infrastructure, proper sanitation, and other things. So that already makes the settlements vulnerable. On top of that, we practice a lot of lifestyle things in India, which are inherently very Indian in their nature and which you would hardly see in any other parts of the world. For example, we use the outdoor spaces for a lot of activities. For example, if there is a street, the street is not just a street for a pedestrian to walk. It has probably shops on both sides where probably some food stalls are there where somebody is cooking a samosa or somebody is preparing a tea, and then there are small shops around where probably somebody is selling certain thing. There are small shops or like in Kolkata there is a concept called rock. Rock is essentially the outdoor patio of your house where people sit and do a little chit chat and such kind of things. So a lot of such type of outdoor spaces are prevalent in different Indian cities, which has very heterogeneous activity. So it's important to understand how thermally comfortable or how thermally uncomfortable those outdoor spaces are, since they are occupied by people for most of the day. So I was talking about different types of outdoor spaces. So I'm going to talk about Kolkata. So in Kolkata, generally we can see three types of built-up spaces. One is the traditional residential settlements, which is like the old city core with courtyard type of houses with thicker walls, narrow streets, and uh, like streets are so narrow that most of the times sunlight cannot enter the streets. These are generally seen in several parts of North Calcutta. Followed by that, there are traditional mixed-use houses or settlements where probably the house is used for the residential purpose, but the ground story or some attached area is used for some other purpose. For example, like somebody is residing inside a house, but probably the ground story is utilized for setting up a shop or maybe setting up a small manufacturing unit or something like that. These types of settlements are predominantly seen across different parts of Kolkata, not just confined in any one part. And other than that, there are slums and squatter settlements, very haphazard in their pattern, mostly situated in like precarious marginal lands of uh, of the railway track or maybe on side of some canal or things like that. So these are some of the spaces which are very important because people spend a lot of time in these spaces. But unfortunately, when we talk about mainstreaming climate actions into our special planning or urban planning processes, these factors are generally not considered. So that sets the premise of my research, where I seek to understand how the necessity of different activities help in transforming a place. And when a place is transformed, then how the transformation is impacting the microclimate as well as the thermal comfort. So when I'm talking about space transformation, what is that? As I was mentioning, a lot of people use a lot of spaces for mixed use and other activities. So let's take an example. There's a street. I want to sell certain thing, but I don't really have like a proper commercial unit. So a lot of times in different parts of India, we can see that people are just setting up a temporary shop, like 4 bamboo or 4 sticks on 4 sides, and then one tarpaulin sheet or one asbestos sheet on top. So that's like a temporary encroachment, which is generally used for something like selling something or maybe some activity or displaying something, etc. So such kind of transformation has the capability of impacting the microclimate. So that's what I tried to understand in my doctoral work. So this work took place between, this particular research took place between July 2017 to December 2019 in different parts of Kolkata. And I'll slowly discuss who is my catering population and what inferences I got from this research, what was my research methodology and other things. And lastly, how that is important. So as you can see, these are 3 neighborhoods that I chose. 3 of them are very popular in Kolkata. So Boipara is essentially a book market, which is part of probably Asia's largest book market or something. It's situated in a place called College Street in North Calcutta, where streets are occupied for setting up a lot of temporary bookstalls. Followed by that, there is Malikhat Flower Market, which also happens to be Asia's largest flower market. And this is completely informal because this is situated on a street stretch under the Howrah Bridge. And this doesn't really follow any urban planning regulations or any building guidelines. And most of it are situated on the side of like a circular railway track and very close to the river Ganges. And the third one is Kumar Tuli, which is a pottery and idol making neighborhood. So as you can see, some like clay kind of thing is visible in the image. So this is also very important in terms of its economic potential, because this is the place where all the Durga Puja idols are made. And this place even like has a turnover of something like 1 million US dollar annually or something like that. And a lot of the Durga Puja idols, the Durga idols are sent abroad as well. So 3 of them are very important in terms of their economic potential. And that's why a lot of people are occupying these spaces throughout the day. So it's essential to understand whether they are susceptible to heat related vulnerabilities, because Kolkata becomes really uncomfortable during summer, and it's generally hot in during most part of the year. So what I'm exactly trying to do here, my work is associated with a particular domain called human biometeorology. So what is human biometeorology? Uh, let's break the word. Biometeorology is essentially the impact of meteorology on bio. So human biometeorology is the impact of meteorology on human biology. So that's very much like how weather impacts your physical health condition, physiology, as well as your thermal satisfaction with the surround. It could be other type of satisfaction as well, like humidity satisfaction or something like that could be. And this is not a very like objective understanding, because this includes a lot of subjective parameters as well. Because how we are feeling thermally comfortable or uncomfortable with our surrounding is dependent on various subjective and objective parameters. And they can directly impact the mortality and morbidity of a particular human. So now how that operates. There is something called human thermoregulatory process, which is basically the heat exchange between human body to the human skin and from human skin to the surrounding environment. So essentially, it's a two-stage model in most of the cases. So we eat something, we do some physical activity. Because of that, some sort of metabolism generates. So when metabolism is generating, our body is also generating heat. and we are trying to dissipate that heat beyond a threshold. Otherwise, if we are like too much heated up, we might end up developing a condition called um, hyperthermia, which is like when your body temperature elevates drastically. It's like heat stroke, like very high fever, which is beyond control or something like that. And then if your body temperature falls really quickly, that's called hypothermia, where your body temperature is probably um, below 96 or 95 Fahrenheit or something like that, where you are losing your body heat. So you need to be insulated from outside, otherwise you will collapse. So both the cases can be fatal, and we need to avoid that. So Kolkata is not really susceptible to hypothermia because no like cold related stress is observed here. But Kolkata is very susceptible to hypothermia because a lot of like hot and humid condition happens during the summer, and that makes you susceptible to vulnerability. So what are the aspects that are important? So metabolism, as I already mentioned. Other than that, clothing insulation, because what type of clothing you are wearing, that can impact your bodily thermal condition. So clothing insulation is the other thing. Other than that, sweat rate. Through sweating, we dissipate a lot of heat. And also, when we don't need to sweat, we can store the heat inside our body by not sweating. So sweat rate is essential in a humid context like Kolkata. So this actually involves the entire heat transfer process between human body and the surrounding environment. Now, why it's important for a city like Kolkata? If you see, if we uh, if we discuss this from a two-dimensional perspective, so we have certain type of informal settlements in one hand, and then we have components of outdoor thermal comfort in the other hand. So now we have discussed what are the different types of settlements, and there are factors associated with thermal comfort. Now, people are wearing a particular cloth, people are eating certain food, and then they're doing some physical activity in a particular space. So the space needs to be comfortable in compliance with what they are wearing, what they are eating, and what activity they are doing. So if the place is not comfortable, we can ensure the comfort by understanding why the place is not comfortable. For example, there could be too much of heat, there could be too much of sweating, there could be lack of wind flow, there could be direct sun exposure, and such kind of things. So then comes the intervention that you might plant a tree, which can give you shading, which can also enhance the wind flow and things like that. That's how this entire process is related. Like the type of settlements is related to the components of outdoor thermal comfort. So what are the objective parameters? I have been talking a lot about the subjective and objective parameters. Objective parameters are essentially the weather condition. It's like the air temperature, relative humidity, wind velocity, wind direction, and the globe temperature, which is related to a radiative parameter. Like how much radiation is happening is related to the globe temperature. Then we have subjective parameter. Subjective parameter can be like personal parameter, like what is your age, height, weight, BMI, what is your sex, what is your ethnicity. All these things can impact the thermal condition of your body. Other than that, the physiological parameter, what type of clothes you are wearing, what is your present metabolic condition, like what activity you are doing now, and what was your immediate past metabolic condition, like what you were doing 15 minutes back or 20 minutes back or something like that. Whether you were exposed to AC or fan or something like that, or sometimes also duration of stay in a particular place can impact the thermal comfort perception or the sensation. For example, if you are staying in Kolkata for a long time, you are already habituated with the hot and humid condition. So you know this place is going to be humid. You adapt yourself accordingly. But if you are someone who is probably staying in a cold environment and coming to Kolkata for the first time, your struggle will be different from this person. So that's like the duration of stay in that place, whether you are acclimatized or not. Other than that, psychological parameters also play an important role. As I mentioned, um, if you are aware that this place is going to be hot and humid, you already know that you cannot do anything about it. So your mind is already set. So in that condition, if you are facing a lot of humidity or a lot of heat, you are not really giving an importance to that. You are thinking, okay, this is normal. So this is not something significant. Let's just get over it and do whatever I'm doing or something like that. But if you don't really expect the weather to be like this, we sometimes exclaim things like, oh, this is so hot today, or this is so cold today, or this is so windy today. So that actually can alter our sensitivity. Other than that, the visual and audio comforts are also important. The different type of sensory comforts and behavioral parameters, they can clearly impact your metabolism. Like if you are drinking tea or coffee, of course you are going to feel hot. If you are drinking ice, like something like if you are eating ice cream or maybe drinking cold drinks or something like that, that's going to give you a lot of like cooling sensation. Again, food intake, like certain kind of food generates more heat, like the proteins generate more heat. If you are a meat eater, probably your metabolism is higher. If you are a vegetarian, your metabolism is lower, and things like that. So why I'm talking about all these things? What is the application of human biometeorology? So if we know human biometeorology, we can understand what are the bioclimatic design principles, like how we can design a particular space, keeping in consideration both the biological as well as the climatic parameters together. And since we know various parameters like acclimatization, physiological adaptation, and we have information of like clothing value, metabolism, age, sex, BMI, socio-ecological factors, and such things. We can also cater to different demography. Um, if we have these information, we can understand what is going to be the difference in thermal comfort perception between probably um, a community which is a heavy meat eater or a community which is fully vegetarian, or maybe a community which wears a particular type of clothing and the other community which wear some other type of clothing. Or this also varies with respect to age. Older people and children are more sensitive towards changes in perception. Sorry, they are lesser sensitive towards change in perception. They don't really understand minor changes. And female are more sensitive towards the colder environment than men. And also this has a direct impact on tourism planning. So if I am being able to make a particular place thermally comfortable, and if that's a tourist space, like we can anticipate more amount of footfall or something like that. So now talking about my research, I was like, by now I was only talking about biometeorology and setting the premises. So now I'm getting into the detail of what I did in Kolkata. So this methodology is adopted from the paper Banerjee Medal and Chattopadhyay, which was published in 2020 in Science of the Total Environment. I'll give you the list of publications towards the end of this slide. If anybody is to know more about this, you can refer the publications. So we conducted a thermal comfort perception survey between November 2018, August 2019, in three neighborhoods in Kolkata with more than 300 samples. We um, we measured the climatic parameters like the globe temperature, air temperature, relative humidity, and such things. And we asked people questions about their thermal perception. So it's like two things were happening simultaneously. We were asking people about how they were feeling at that point of time, and we were capturing the climatic conditions simultaneously through the measurements. And this particular study took place in three places, as I already explained, and we sort of followed all the conventional rules of like urban climate field studies and other things. So if you see, these two images are from College Street, Boipara, which is the book market. Um, this was our setup of the climate data collection. And these are some of the instruments that we used for collecting the data. This was the corresponding questionnaire. We asked people questions about their physiological information, their acclimatization, their age, sex, ethnicity, height, weight, what sort of clothes they are wearing, and like what was their previous activity level, whether they're standing or like sitting or whatever, like whether they're in a shaded place or not. And other than that, there were questions about their perception, like how cold or how hot you are feeling at this moment, and how do you want it to. Like if somebody uh, like answered that, okay, I'm feeling neutral. We wanted to understand whether that's okay with you. Like you are feeling neutral, is that okay, or you want to achieve a little bit of coolness or things like that. So such kind of questions were asked, and then we try to understand the psychological parameters like expectation and acclimatization, and like whether they have some other behavioral parameters as well, like what type of food or drink and such things they have consumed in last 15-20 minutes. So now we have a huge amount of data collected from these 300 plus responses. So we used a three-stage linear regression based model to understand which type of variable has the most significance on shaping the thermal perception. So we use different linear regression models in each stage. And this methodology is effective because for this particular case, you see this is a three-stage model. So for each stage, we we added like one extra step of variable. So for the first stage, we were only considering climatic variable, like whether uh, the air temperature, relative humidity, and such things can only impact the thermal comfort. In the second stage, we entered the physiological variables. So now it's like climatic plus physiological. What is the impact of that on thermal comfort perception? And in the third stage, we entered other things like climatic, physiological, perceptual, behavioral, and all other type of variables. And then what was the impact of all of these, like all the variable ensemble on the thermal comfort perception? So we use different types of regression methods for this. Again, if you would like to read more about this, you can read it in Banerjee and Chattopadhyay paper 2020. So our results showed that different type of variables can impact the thermal comfort perception. So this is like one particular graph which shows that you're going to, like, I'm not getting into the technical detail of what is PET or what is MTSV and such kind of things because they're like technical. I understand that not everybody here belongs to the human biometerology background. So I'll just explain. So it's like if the temperature is higher, you are going to feel uncomfortable. Or maybe if the wind flow is stagnant, you are going to feel uncomfortable. And how much discomfort is there owing to what change in wind or temperature or such kind of things, they can be deciphered from these graphs. So these graphs were generated for all the neighborhoods for like both seasons. We conducted a survey in summer as well as in winter to understand if there is any seasonal variation. So after that, we also try to understand what is their preference. Like so far, we were only checking the perception. Now we are trying to understand what is their preference. So if I just sum up the results, so our study showed that presence in the location during last 20 minutes. You would probably remember there was one such question in the questionnaire, like whether you are present in this location for last 20 minutes. So presence in the location during last 20 minutes, as well as expectation about the place were found to be significant variables impacting the overall sensation of respondents. And that actually shows the importance of acclimatization. If you are acclimatized, you don't feel uncomfortable. And like people generally responded comfortable sensation if they were seated or they were under shade or um, sometimes like they got rid of the clothing. So it's also very like common phenomena in different parts of India where you see that probably a lot of men are sitting like bare-bodied outside because they are feeling hot, so they just got like they get rid of the clothes. So that's also one of the cooling mechanisms. So that's like adaptation. Um, it was very surprising to see actually a very less number of people responded that they were drinking water or like they were eating something cold to feel cooler. They were trying to get rid of the clothing. They were trying to look for an air-conditioned space and such kind of things to feel comfortable. And we can see that only air temperature is probably not going to be a very good predictor of thermal comfort. We need like a holistic approach. So you can see there's something written as PET, which is called physiological equivalent temperature, which is a thermal comfort index, which is a holistic index which takes care of everything like um, climatic factors, physiological, your personal factors like age, height, weight, and such things. So rather than only considering air temperature as a predictor of how thermally comfortable or uncomfortable you are feeling, it's better to use an ensemble index which considers all these variables. Um, some of the other results also show that duration of stay past metabolism and such kind of things um, can impact the thermal comfort perception, and which is also again dependent on different types of micro enterprises. Like as I said, one neighborhood was dedicated for like idol making and pottery and such kind of things, and then the other neighborhood was dedicated to flower markets. So the activity wise these neighborhoods are different. The other neighborhood was for like book selling. So whatever activity they are doing, like in terms of physical activity also, they're very different from each other. So their metabolism is going to be different from each other. So now all these results generated that if you are in Kolkata, you are going to feel thermally neutral, like you're neither feeling cold nor feeling hot at a temperature range between like 19.5 to 27.6 degrees centigrade. And these are like thermal comfort scales. So you are going to feel slightly cooler at anything which is lower than 19, which is between like 11.4 to 19.4. You are going to feel even more cooler at like temperature lower than 11 till 3, and then you have extreme cold with something less than 3. And then you have like slightly warm between 27.6 to 35.7. You have warm between 35.7 to 43.8, and then you have hot at temperature more than 40. So what is the utility of this particular information? So it's like if you know what is the temperature range after which their comfort threshold is going to be challenged, then you can ensure that you are proposing some um, uh, intervention which is capable of ensuring your comfort in compliance with this particular standard. So now I'm talking about now I'm going to talk about that part. So this is like one reference which shows what is the neutral range in different parts of the world and what is our like conclusion from Kolkata. So you can also read this thing in the Banerjee lecture. So now talking about the intervention. So these were the three neighborhoods in Kolkata. So we used a three-dimensional computational fluid dynamics software called Informal, which can perform microclimate simulations. So it's like we are creating the virtual environment and we are trying to add different mitigation strategies to understand which one performs better. Because in real life, we cannot really, like add the mitigation strategies and see if that is working or not. So it's better to create something similar in a virtual space and then add options and see if that's working or not. So I'm going to talk about like only College Street now. So we tried to understand because of these informal activities, as I talked about the space transformation, like temporary encroachment and such kind of things. So whether these temporary encroachments are creating more heat or they are actually cooling the environment. So that's something we are going to see now, because by now we know what is the thermal comfort range. So now we need to see whether like creating those temporary encroachments can provide you thermal comfort, um, which is complying with the that previous chart. So if you see, this is one of the outputs of air temperature from the simulation. So predominantly you can see the air temperature is between like 25 degree in most of the like between 25 degree to say 33 degree in most of the cases. So now this is somewhat comfortable, because if we go back to our previous case, like something between um, 23 to say 35 is on the slightly warm state. So this is still okay, like not very neutral, but this is still okay. This is not going on the extreme bar. This is not crossing the 43. So similarly, this is humidity. This is mean radiant temperature, which is the other similar microclimate variable comparable to air temperature. This is the humidity map, and okay, so this is something interesting. So when we were talking about the encroachments, in this particular exercise, what I tried to understand what is the effect of encroachment. So how about understanding the base case, which is like the encroachment case, and a hypothetical case which doesn't have any encroachment, like clear streets. So let's just assume that there is a hypothetical case of the same neighborhood, but there is no encroachment. So now I have the encroached existing base case, and I have the hypothetical without encroachment scenario. So this map is actually the subtraction of the existing base case minus the hypothetical without encroachment. So now you can see what is the impact of encroachment. All the blue lines that you can see are basically the encroached areas in this particular neighborhood. So if you look into the difference of mean radiant temperature, this actually shows that owing to the presence of the encroachments, you can actually achieve 10-degree cooling. So that also shows that shading is capable of providing a lot of comfort, because eventually when you have temporary encroachments, you are not really directly exposed to the sun light or the sun radiation. So then um, cooling is dependent on the shading that you are being able to provide inside a street. Now, talking about different cases, like this was just one case that I showed. So this is for Boipara, College Street. If I go back, in College Street, if you can see in the screen, there are small linear stretches of like green encroachments. If you can see, like there is a vertical line of green encroachments. This is more like a linear stretch. But if you see into other neighborhoods, in in the in the neighborhood which is on the top right part of your screen, there are a lot of like bigger stretches of encroachments. Like all the green things that you can see, of course, other than the trees, are your encroachments. So it's like they are forming some sort of like a courtyard formation or something like that in some of the cases. And in the bottom right neighborhood, this is the flower market. So if I go back, there was no like built up structure. So what people do there to provide themselves shade, they use like a lot of umbrella or such kind of things. Like if you see the second image, towards the farthest corner of that image, can you spot some umbrellas? Like people were carrying umbrellas and such kind of things. So if I again like go back to the slide. Yeah. So now I have three different types of encroachments. One is the linear stretch, the other one is the courtyard type of encroachment, and the third one is just discrete umbrella. So our results show that the type of encroachment is also impacting the amount of comfort that it's providing. So like in the flower market, umbrellas helped in lowering the mean radiant temperature, but these discrete umbrella-like encroachments were less effective in providing the comfort. Whether like it was irrespective of like what type of umbrella you are using or something. It was just like one discrete umbrella. But for the other two cases where we have like a linear stretch or maybe like a cluster of encroachments, they were providing more comfort. So if I talk about these three neighborhoods, the umbrella neighborhood had the highest heat compared to the other two. So that's pretty much explains like why it's important to consider like the like climatic consideration into your spatial planning, because now we can see that we can actually understand how effective like an intervention strategy is going to be for heat mitigation if we just plan it properly prior hand. um, if we can simulate different options and if we can see what is going to be their like relative efficacy in lowering the stress, uh, that is going to be really effective. So if you are interested to know more about these things and like more details of research methodology and tools and other things, you can have a look at these publications. And yeah, these are some of the references I used. So thank you everybody for being patient. That's my presentation. Over to you, Aditi.
Yes, thank you so much, Shreya. That's a fascinating presentation on the urban heat and his mitigation strategies. I'm sure my colleagues have questions. I see Syed Adil Mizan. I'll just let you talk. Adil, please go ahead, ask your question.
Hello, I'm audible?
Hi,
Yes,
Adil.
Yeah.
yes, you are audible.
Yeah, thank you, Shreya, for a very nice presentation. It was really a little bit new for me. My question is that little bit based on my own experience. Uh, I'm a little bit curious about that, about the role of topography in the microclimate, because I know that Kolkata doesn't have much variability in the topography, but if you will talk about the southern India, where much undulation is there within the city, like Hyderabad, where I lived. So I felt that when I was driving the bike during the summertime, when I go to the depression, I felt a little bit cooler as compared to the upper portion of that city. So I just want to know a little bit the role of that things in the microclimate scenario.
Okay, thank you, Adil, for your question. I think that's a really interesting question. And yeah, just as a small anecdote, I stayed in Hyderabad for a year, so I sort of understand like what you were saying.
Yeah.
So okay, yeah. So coming back to your question, okay, it's about the scale. So, when I'm talking about the micro scale, it's like it's just 100 meter by 100 meter, like one neighborhood. So if, since you are from Hyderabad, probably I'll just give you context. Like maybe I'm only talking about the uh, say just any like okay, maybe I'm if I'm considering the entire say Madhapur, I'm not talking about the entire Madhapur. I'm only talking about probably um, the Image Hospital area or maybe the Ayappa Society area or something like that, which is like very small, like 100 meter by 100 meter or 200 meter by 200. That's why it's micro scale. So what you are talking about is basically mesoscale, where it's beyond the level of only just a neighborhood. It's like different neighborhoods together. So when you are probably like traveling from one part of the city to the other part of the city, you can clearly see the difference because of like the slope or maybe the elevation from the sea level and such kind of things. I think that thing is also present in Kolkata because Kolkata is like has like a very unusual topography. So Kolkata is it's actually like a bowl. The topography of Kolkata is actually like a bowl where towards the river it has the higher elevation of the land, and towards the central part um, the land elevation is lower than the bank of the river, and that is one of the reasons why so much waterlogging happens in Kolkata, even during like very like little rain or something like that. So what you were saying is extremely important when we talk about mesoscale, and I think a couple of tools are really important. Like if you look into WRF, which is like WRF, so that full form is weather research forecasting or something like that. So that particular tool has been used like several hundred times to do such studies. So if you just look into any of the WRF studies, I think that will like give you more context of how much change you can observe with respect to a change in the topography or something like that. So the scale is different. That's it.
Thank you.
Thanks,
Thank you.
Shreya. Before there are more questions from my colleagues, I was quite curious about the wet bulb temperature. In the IPCC and otherwise, the climate scientists have been telling us that a wet bulb temperature of 34, 35 degree can be actually lethal. And
Right.
Kolkata with its high heat and humidity. So how does your methodology, so the perception part includes both heat and humidity?
Mhm.
And what I also understand about the research on high humidity and high wet bulb temperature is um, perhaps I don't know how to put it, but perhaps I may not be perceiving such a huge amount of discomfort. But even without that, given that those are physiologically impossible levels, people just collapse and then almost
Right.
you can't do anything. I don't know enough about the topic, but it all sounds very scary. So can you tell us a little bit more about what happens when there's a conjunction of high humidity and high heat? Thank
Thank
you.
you, Aditi, for your question. Yes, you're absolutely right. So, in my research, I considered the dry bulb temperature, which is like the thermometer temperature. So, since I considered the dry bulb temperature, I had to measure the humidity separately. So, when I was talking about the thermal comfort index, which is PET, so PET considers all these factors together. It also considers the solar radiation, like the amount of direct sun exposure that you are subjected to. Also, the wind, whether it's like wind-wise comfortable or it's very stuffy and you're feeling that there is no wind and such kind of things. So that's why PET is used, because that's holistic. That's rather than just one temperature, it gives you the holistic perspective. So as I was saying, a lot of people can't really differentiate between how much hot is too much hot and how much hot is bearable hot or something like that. So then, especially the senior citizens, the elderly people, or maybe the kids, they don't really understand. So if we like survey that particular demography, if we survey those people, and then if we come up with an understanding of what is going to be their range, like in my case, I was considering the thermal comfort range of probably a bookseller or an idol maker or maybe a flower seller. So if we consider, a population which only has like elderly citizen or like senior citizens, then we will be able to come up with one such table which is going to give us the idea of how much hot is going to be too much hot for them and how much hot is going to be bearable. So accordingly, we can come up with recommendations.
Okay, aren't those information already available based on medical studies, physiological studies about what is that threshold beyond which human body cannot take that heat and humidity?
Yes, there are thresholds, but there are like very general thresholds. Like as I
Okay,
was talking,
okay,
there are things like hypothermia and hypothermia. Like this is common knowledge that if your fever is like
right.
more than 104 or something, it's
Yeah,
harmful. That
right,
might be
right.
or something like that. Yeah, but like
Okay,
uh, yeah, human biometeorology is more like when you are considering the surrounding spaces also, like
okay.
how you should design a building so that the building is capable of providing that thermally comfortable environment.
Right, right. Understood. Yes, Orchishman, you have a question you can ask. Go ahead.
Hi, Shreya. Thanks for the presentation. So my question is probably a bit naive. I'm very layman to the topic, so please
That's totally
forgive.
fine.
Yeah,
Please go
yeah.
ahead.
So just to understand, for example, when you were saying these encroachments help in reducing the field, so that's because there is more. Basically, if I understand, when there is more shade, so people under the shade are feeling cooler, or is it also affecting people who are standing in the heat in that region? So that's sort of just to clarify my point. And the second thing is when you do the simulation, you're sort of comparing with encroachments and without the encroachments. But for example, without the encroachment could also have trees, shaded trees. So that would be very different. So why not consider that while comparing the encroachment vis-a-vis non-encroachments? Thanks.
Okay, so I'll answer your second question first. Since it's a scenario, so it's like when there is an encroachment, um, since I'm talking about only the physical space, like the spatial planning from an architect's and an urban planner's point of view. I am considering only the built-up space. Like, of course, you are right. There could be like a tree and tree-related shading and something like that. So that will be a different case altogether. In my case, I only considered the built-up structure. So if there is a temporary encroachment, if that's like imparting more heat or generating like more cooling thing or something like that, and also the all the areas where I did my survey, they're like already heavily dense and heavily packed up area. You hardly have like any more room for even like planting like a small tree or like um, anything which is significant. So if you are keen to know more, there are like a lot of studies available which discuss the impact of tree on thermal comfort. So it's also like if you only plant bigger trees, like maybe a big mango tree or maybe a big banyan tree, they are only capable of providing you significant shading. If you just plant like a small shrub or something, they're probably not that effective. So until I have the space and the room to plant like a large banyan tree or maybe a mango tree or a tamarind tree, there's not much effectivity of plantation. So that's your second question. And coming back to your first question, yes, you got it correct. When I'm talking about the cooling from the temporary encroachment, it's because of the shading. So I was talking about mean radiant temperature. So other than any microclimatic variable, like other than air temperature, relative humidity, wind flow, or anything, mean radiant temperature is the variable which has the highest impact on human thermal perception, because that's like that considers human body from like all surface, and that's directly like related to the radiative heat exchange that human body does with its surrounding. So mean radiant temperature is very sensitive to shading. So if you can improve the shading and if you can make sure that people are not directly exposed to sunlight, then probably their thermal comfort will be increased manyfold, even for the same magnitude of like, say, like if you are being able to reduce the median temperature by 5 degrees by providing shade, and if you are reducing the air temperature by 5 degrees, by some means, people will feel more comfortable when 5-degree reduction is happening in the median temperature rather than the air temperature. So our objective is always to reduce the mean radiant temperature, because if we are able to do that, rest of the things will automatically fall in place. So that's why it's always like recommended to provide like more shading, and shading is also like dependent on the sun angle. Like when the sun moves from like west to east, the shading changes. It has like a proper profile. So all those things are taken into consideration. That's how the cooling thing was obtained from the simulation results. I hope that answers your question.
Thanks a lot.
Yeah, thanks, Shreya. But I was wondering what the encroachment material doesn't matter, because by encroachment, I understood those temporary structures. So
Right.
many of them are polythene sheets.
Right.
So is there anything, any literature that's around, the type of those shading structures and whether there are better or others? And you can take my question along with they, if you can ask your question, please.
Yeah, thanks, Aditi. Yeah, I had a similar question to what Aditi just mentioned. Like, did you collect any information on different building materials as well as roof materials? Because radiation may vary based on them. So that was one question that I had. Thank you.
Okay. Thank you, both of you. Yes, I did have the building material data, because when I was simulating, I was trying to create like a virtual case, which is like as close as to the reality. So like whatever material was used in that neighborhood for like whatever building, I sort of like considered that for all the simulations. So it's a very important question, because mostly the radiative heat exchange is dependent on the albedo, which is like one of the properties of the surface material. But in this particular case, okay, I'll come back to the roof thing first. Since I was talking about pedestrian, so the roof thing is not really significant here, because pedestrians are mostly at like 1.5 or 1.8 meter high. Whereas like most of these buildings are 3-4 story buildings where the roof was like at say 15 meter or 20 meter or such such height. So maybe if I was to like consider the thermal comfort of somebody who was at the terrace, then probably that thing would have been considered, and that thing would have been significant. So in this particular case, the roof thing was not significant. And coming back to your question, Aditi, so we did check the sensitivity of the materials and their corresponding thermal comfort or discomfort capability. But what we saw, that impact of them was comparatively negligible compared to the amount of shade and the presence of shade that they are providing. So of course, like when I checked, like there were asbestos shades, they were hotter compared to the polythene shades. But the amount of cooling that it was providing underneath the shade was more impactful. So yeah, I think that's the answer.
Okay. No, that's absolutely fascinating. So with that, I don't see any further questions, and we are dot on time. So I would say this was a fascinating talk. And I think one part that we perhaps have not covered, because these were the vulnerable populations who may not be able to actually use air conditioners.
Right.
And now, so what happens when we have more and more air conditioners? I suppose that's a topic for another seminar, because air conditioners then itself cause more carbon emissions, and we
Right.
get into that loop. We also get used to more of that thermal comfort, etc. So that's I think this whole topic around how do we provide thermal comfort in our tropical cities under a changing climate is such a crucial topic. And all of us are water people. So thank you, and coming to talk to us on a topic that we are interested in, but we haven't really worked on. So thanks a lot. Thank you so much. And for the rest of you, we would have our next seminar happening